Hello, everyone. If you have recently started working with Microsoft Foundry, you have probably comes across the terms like the Foundry resource for the project endpoint, and the OpenAI endpoint. And you must have wondered what these are endpoints, or what or which SDK you have to use. They use this project endpoint or the OpenAI endpoint for my application. What's the difference between the chat completions API and the responses API? If these questions sound familiar to you, then this video is for you. By the end of this video, you will clearly understand the Microsoft Foundry architecture and know exactly which endpoint to use for your application. Let's start from the top. Microsoft Foundry is Microsoft's unified AI development platform. Instead of managing multiple AI services separately, Foundry brings everything into one portal where you can build, deploy, test, and manage these AI applications. Think of it as a complete workspace for your AI development. Inside this Foundry, you can deploy the OpenAI models, build the agents, create vector indexes, connect enterprise data. You can run evaluations, monitor these applications, and everything is managed from a single portal. If you look at inside your subscription, you will be able to create Foundry resources, which will give you access to the Foundry portal. So if you have a valid Azure subscription, you will be able to log into the Microsoft Foundry portal using the ai.azure login page. And once you have created your AI resource, that is your Foundry resource, inside this, you can create one or more projects. And each project can have multiple models deployed inside it. You can deploy the agents, you can have connections, create the vector indexes, and you can do deployments of your AI apps. What is a Foundry resource? A Foundry resource is a software resource that hosts your AI environment. It manages the building, security, networking, authentication, model deployments, and even the projects. You can think of this as a parent container, just like the storage account can contain multiple containers. A Foundry resource can have multiple projects inside it. So when you create a Foundry resource, you first create a project and deploy the models, create the agents. When you start using these models and agents, that will be reflected in the billing. And you can configure security for your projects using the RBAC, and you can configure private network access, enable authentication via Entra ID, and you can deploy OpenAI and non-OpenAI models inside your project. So now think, what is a project? Inside this Foundry resource, you will be able to create different projects. A project for human resource department, a project for market research department, or marketing or research department, or you can even have a data analysis project. A project is your team's workspace. And inside this project, as I mentioned earlier, you will be able to deploy models. You can create the AI agents, create your data sets, vector indexes, and you can do evaluations for models, agents, and data sets. It allows different teams to work independently while sharing the same Foundry resource, which means you can create different projects for different departments or teams, but all these comes under a single Foundry resource. You can start working with your Foundry resources in two ways. Either you can create a Foundry resource in the Azure portal, or you can directly go to the Foundry portal and create a project. While creating the project, it will automatically create a Foundry resource. So now, if you are trying to create a Foundry resource through the Azure portal, you can navigate to the portal's homepage. You can see a Foundry resource type, or you can go to create a resource section and then search for AI action agents, and you will see the Microsoft Foundry resource type. Select that, and you can specify the subscription type, subscription resource group, the name of the Foundry resource, and the region where you want to deploy your Foundry resource. And you can also provide a default project name. So within a single Foundry resource, you are able to go and create multiple projects. But if you want to create a Foundry resource, at least one project you need to create. So the default project will be the default project or initial project created along with the Foundry resource. If you want to create your Foundry resource and project directly from the Foundry portal, you can log into the Foundry portal using the same credentials that you use for your Azure portal. Once you log in successfully into the Microsoft Foundry portal, you can click on the Start Building. You can start creating a new project by clicking on this Create New button. Or if you have an existing resource and project exists, you can select that. So in this case, I'm going to create a new Foundry project, and that's going to create a new Foundry resource as well. So let me click on this create, and here we have two options. One is to create a Foundry resource, and second one is the AI Hub resource. So in this session, we are not going to discuss about the AI Hub resource. We are going to discuss only about the Microsoft Foundry resource. So this is the recommended approach for the new projects. So I can select the Microsoft Foundry resource, click on next, and it's now asking for the project name. So you can specify the project names in lowercase. Training project 01 is the name of the project that I'm going to give. And you can specify the Foundry resource name here. So maybe you can give the same name, or you can just give your own name, and select the resource group and subscriptions here. I'm going to select the AI group, which is an existing resource group. And here we can select the region. So you can select any region where you want to deploy your Foundry resource. I'm going to select the East US 2. Click on create, and it may take a few seconds to create this project. You can see now the project is created, and this is the dashboard for the Foundry project. Here in the dashboard, you will be able to see the API key for your project, and there is a project endpoint and Azure OpenAI endpoint. Let's go to the build menu. In this build section, you can see what we can create and deploy in Foundry projects. We can have agents, models, services, tools, knowledge, guardrails, memory, and data. And for optimization, we have evaluations and fine tuning. Now, first, we can deploy some models inside your project. So let's go to the models section, and under this deployments, we can deploy a base model. You can search for the available models. Not every model is available in all the regions. So for example, if I have to deploy a GPT 5.6 SOL model, so let's select this. Now, if the model is available, you will be able to see the default settings option is enabled. But here you can see this model is not available due to insufficient quota. So that means you will not be able to deploy that model. So I can go back and search for GPT-5 model. Let's check whether this model is available for this region. So this model is also not available for this particular region. Or we can try for GPT 5.4. Yes, you can see this option is enabled, which means you will be able to deploy the GPT 5.4 model in this selected region. So I can click on this default settings to use the default values for deploying this model. Yes, the model is successfully deployed. So now we can access this model using the endpoints available for your project. So here we have the project endpoint and the Azure OpenAI endpoint. Now let's talk about the endpoints in the Foundry project. The first endpoint you will notice is the project endpoint. This endpoint represents your entire project, not just the deployed model. It's a project aware, meaning it understands all the assets inside your project. Using the project endpoint, you can work with the AI agents, conversations, evaluations, even files, vectors, project resources, OpenAI compatible APIs. But this second endpoint, that is the OpenAI endpoint, it is an OpenAI compatible endpoint. It is primarily used for the model inference. So this is the endpoint that your application uses when you want to generate the text, create embeddings, analyze the images, or generate the responses. If your application only needs to send the prompt to a particular model and receive the answers or responses, this is usually the endpoint that you will use. If you are building an enterprise AI solution with agents, files, conversations, evaluations, this project endpoint is the right choice. If you're simply integrating the GPT models in your application for generating the text or embeddings, then the OpenAI endpoint is the better fit. So many real-world applications uses both the project endpoint for managing the AI assets and the OpenAI endpoint for the inference. For building these AI applications, we have two SDKs. One is the Foundry SDK and another one is the OpenAI SDK. You can use the Foundry SDK when you interacting with the project resources such as agents, evaluations, or other project scoped capabilities. And you can use the OpenAI SDK when your goal is model inference using the OpenAI compatible APIs. For authentication, you have two common options. Either you can use the API key or you can use the Microsoft Entra ID. For the production applications, Microsoft recommends the Microsoft Entra ID because it avoids embedding the secrets and integrates with the Azure identity and role-based access control. Another important concept is the evolution from the chat completions to the responses API. The chat completions API is designed specifically for the conversational chat. The newer responses API provides a unified interface that support modern capabilities such as tool calling, structured outputs, multi-modal inputs, and the reasoning models. So if you look at this table, you can see primarily we use the completions API. That's a legacy API for simple text generation. That means text completion operations. The responses API, that's a new and the recommended API for the new applications, and that is a unified API for generative AI applications and the agents. So when you talk about the inputs, the completions API takes simple prompt as an input, but the responses API can take multi-modal inputs which may contain the text, files, or images in the prompt. Output of this completions API is basically the text output, but the responses API may generate more rich responses. It can include the text, tool calling, data, or maybe some other artifacts like files. And tool calling is not supported in the completions API, but if you want to integrate some tools in the model calling, or while invoking these models, you can do that with the help of this responsible API. So web search or code executions or some function executions can be done with the responses API. And for conversation management, we usually manages the conversation history. So when you use the completions API, it is the responsibility of the client application to manage or maintain the conversation history or conversation context. So when you send a new message, you have to attach the new message with the array of history messages. But in case of responses API, we don't need to send the entire message history while sending the request. So you can integrate or you can add the response ID. This is the previous response ID in the message, and that will automatically identify or access the previous conversation history and generate some context-aware responses, which means the API will be taking care of, or the backend will be taking care of the conversational state management. So primarily we use the completions API for simple chat or Q&A based applications. But if you are looking for agents or creating a multimodal workflows or multi-agent workflows or creating some complex multi-modal generative AI applications, then it is recommended to use the responses API. Now let's see some examples for the completions API and responses API. So I have created one Foundry project, and in the .env file, I have saved the Foundry project endpoint, the model name, and the OpenAI API endpoint. So I have both the endpoints stored in the .env file. Now let's see how we can use these endpoints in our code. So first we are looking into this completions API. So for this, I'm using this OpenAI API client with the Foundry SDK. For this, I'm going to install the Azure AI Projects Python package, python.env for reading the environment variable values, and the asynchronous IO HTTP for the asynchronous API operations. Now let's see how we can make the synchronous API calls using this completions API. So I'm importing the AI project client, which is required for creating a Foundry project client. So I'm importing the AI project client from the azure.ai.projects package. And for authentication here, I'm using the Entra ID authentication. For that, I'm importing the default Azure credential. So for this, I don't need to specify the API key. Instead, so I can log in with the Azure CLI command, that is AZ login command I can use to log in from my local machine, and the credentials which are stored in my local machine will be used for authenticating to the Foundry project. So, and also I'm importing the chat completion message param from the OpenAI.types.chat package. Then we are loading this environment variables and then storing this endpoint and the model values into two variables. Let's create the two variables. One is for the credentials and another one is the project client. So for creating this project client, we are passing the endpoint and the credential, which is the Entra ID based credential. So we have this project client, and using this project client, I can make a request. So for that, from this project client, means Foundry project client, we are creating an OpenAI client. So you can call the project client dot get OpenAI client method, and that returns a variable. So here OpenAI underscore client is the variable that stores the reference of this OpenAI client. So now I can prepare the messages, that is the list of messages that we have to send to the completions API or to the LLM model. So we have a system message that is used to define the role and behavior of our assistant. And here is a user message. So when I make a call using the completions API, I can use OpenAI client.chat.completions.create method and passing this model messages and the temperature or the reasoning effort parameter. So it depends on which type of model that you are using. If you are using GPT-5 or later versions, then you should not use the temperature parameter, because the later versions of this model does not support the temperature parameter. So for that, you can use the reasoning effort parameter, which you can set as low or high or medium. But if you're using the older GPT versions, the other GPT 4.1 or 4.2, that kind of models, if you're using, then you will be able to use the temperature parameter. So here I can make a request, and that returns the completion, that is the result or response that's coming from the LLM. And then I can get the assistant message by completions.choices of 0.message.content. And here I can print the assistant response. But now if I have to ask a question which is related to the previous response, or which is connected to the previous conversation, then I have to explicitly manage the conversation history. So for that, I am storing a new message into the messages array. So messages array is used to maintain the conversation history. So here we already have the system message and the user prompt or user message. Now the AI response that we have received just now is also stored into the messages array. And for sending the new message, I'm adding another user prompt into that. You can see The first question was something like, tell me a fact about Eiffel Tower. And we got the response. And now we are asking a question like, give me one related fun fact. So one related fun fact would be mentioned, but related to what is not mentioned here in the second prompt. So from this conversation history, the LLM should be able to understand that we are talking about the Eiffel Tower, and it is supposed to give a fun fact about the Eiffel Tower. So I can make another request. Here you can see I'm passing the messages model and the reasoning effort parameter to the completions API, and it returns a response here. Now let's see what response it gives. I'm running this particular cell. Here is a first response, and here is the fun fact about the Eiffel Tower. So you can see this is the fun fact related to the Eiffel Tower that is coming from the same completions API. Now we can make the same API call in asynchronous way also, but for calling it through the asynchronous API, so we have to use the async method. So here you can use the async keyword, and I am creating a main method which is marked as async, and inside this I'm declaring the project client, then OpenAI client, and the credentials within the async context. So here async with is used to declare this variable. So this will be asynchronous variables or asynchronous type of variables that we can make the request. And here the same way I'm creating the messages list, which contains the system message and the user message. And here the first request, we are using the await keyword because this time when I make a call using this OpenAI client, it is the asynchronous API call. So we have to use the await keyword to get the final response. And here I'm printing this response, then explicitly adding this assistance message and the new prompt or user request into the messages array, and making the subsequent API call, which is also marked with the await keyword, and we get the response and we print it. Since we have defined everything inside an asynchronous main method, we can call this main method using the await keyword. So if you are creating this code or executing this code in a py file, that is a Python script file, so you may have to use the asyncio.run method for executing this main. But here I'm using the Python notebooks. So inside the Python notebook cell, we don't need to use the asyncio.run. I can directly use the await and the asynchronous method name to invoke it. Now let's run this particular cell. Yes, we got the first response, and here is the second response from the LLM. Now, in this example, the synchronous and asynchronous examples, we have used the Foundry SDK because we have used the Foundry endpoint, and also we have used the AI project client that uses the Foundry project endpoint. But the same can be performed using the OpenAI SDK. So here for OpenAI SDK, we have to install the OpenAI package, and we will do the same operation, but you can see what is the difference here is instead of creating the AI project client instance, we directly create an instance of the OpenAI. So OpenAI instance or OpenAI client instance, when you create, we need to pass the API key and the URL. But you can see we are not using any API key inside our project. So we have to generate the API key or extract the API key by making a request. So for that, we can use this method called get bearer token provider and provide the Entra ID credential and the endpoint for the token. So when we create an instance of the OpenAI client, it automatically make a request to this endpoint and get uh, an API key or token, and that will be used for the API key parameter. And base URL, we are using the Open API endpoint instead of the Foundry Project endpoint. And here is the list of messages. We are maintaining the list of messages in the messages of type format or messages format. And we make a request using the OpenAI.client chat.completions.create method, passing the model name, the messages, and the reason. So this is the OpenAI client, but we have directly created this client without the Foundry project instance. And here we will get the response, and we are adding this response into the messages array and adding the new prompt or new request also into the messages history and making the second request. And here we got the second result. So when we run this, we will get exact same response that we have generated using the Foundry SDK. The same can be done using the asynchronous method also. So for that, we just need to create a main method which is marked as async. And we are creating an asynchronous OpenAI instance. So in the previous synchronous API call, we have created an instance of OpenAI class, but this time we will be creating an instance of async OpenAI class. And the parameters are same, that we are passing the API key and the base URL that returns an OpenAI client instance. And with this OpenAI client instance, we are making a request to the LLM. And here we follow the same step as the previous demo. And here also you can see we get the response. We explicitly add this messages to the messages array and then makes the subsequent request, and we get the response. And we can call this main method using the await, since the main method is marked as async. So when we invoke this, this is going to give the exact same response of the previous demo. So you can see the same LLM based operations, or I can make the LLM request using the Foundry SDK or the OpenAI SDK, means without creating a project client. So when you create a project client, you have to use the Foundry project endpoint. But if you are directly using the OpenAI client, then you don't need to use the Foundry project endpoint. You can directly use the OpenAI endpoint. Now let's see how the responses API is working and what are the features that it offers for the developer. So in this demo, I'm using the Foundry SDK as well as the OpenAI SDK. So first, for the Foundry SDK, we have to install the same Azure AI projects package. Along with, I'm installing the other packages like the Python.env and the IOSTTP. And first, the same synchronous call example, but this time I'm using the responses API, not the completions API. So for this, I'm creating the credentials instance, then the Foundry project instance, that is the project client. And using this project client, I'm creating the OpenAI client. And you can see while making this request, I'm using the OpenAI client dot responses dot create. Instead of the chat dot completions dot create, we are using the OpenAI client.responses.create, and we are passing the model name and the input message only, not the complete message list or message history. So we are not passing any messages array here. We don't need to specify any system message or role or anything like that. We can directly pass the input text or the prompt. So we get the response and we can print the response. You can see the response we can access very easily compared to the previous approach. So in the previous example, we have used this completion dot choices of 0 dot message dot content to get the assistance message, and we have passed the messages list also. But in the responses API, we are passing only the prompt message, and we are getting the response. And for printing this response, it's very easy. Just call the response dot output text. Now, if I have to make a subsequent call to the model, then I can again use the OpenAI client.responses.create method and passing this input. You can see here the first question was about what is the size of France in square miles. So we are asking something about the France. And the second question is just, and what is the capital city? Which means I'm asking the capital city of the France. So that means the previously asked question. This is something related to the previously asked question. And one thing which you can notice is the previous response ID. And here we are passing the response. So here is the previous response variable. So the response.id, which is the previous responses ID, is passed as a parameter to the current request. So when you send the new request, we are passing the previous responses ID. So this is helping you to maintain the conversation context. And we are getting the response and printing that response. Let's see whether it is able to generate the response for the first question and generate a related answer for the second question. So let's run it. Yes, the response for the first one is generated, and here is the response for the second one. The first one, what is the area of France? And the second question was, what was the capital city? I was not referring the name France, but you can see the second response contains the name France, which means it is able to understand we were talking about the country France, and it is supposed to generate the capital of France. The same thing can be done using the asynchronous call also. Like the completions API example, we are supposed to create a main method marked with the async keyword, and inside this we are declaring the credentials variable, the Foundry Project client instance, and from the Foundry Project client instance we are creating the OpenAI client, and we are making the responses.create method call using the OpenAI client. But you can notice that we are using the await keyword in front of that, which means this is an asynchronous API call. So the rest, everything is same like the synchronous API call. We are passing the model and input, and we get the response. And here is the second request. Here we are passing the previous response ID along with the message and the model. To invoke this, we are calling this await main, which means this will execute the main method in the asynchronous mode. You can see the response for both the questions are generated. So this is how we use the Foundry SDK. But one thing which you have to notice is whenever you use the Foundry SDK, we are using the Foundry Project endpoint. But the same thing can be done using the OpenAI SDK. For that, we are installing the OpenAI package. But while using this OpenAI SDK or OpenAI client, we are supposed to pass the Open API or OpenAI API endpoint, not the project endpoint. So we can see we are using the OpenAI class to generate the instance, and we are passing the API key which is generated using the Entra ID credentials and passing the Open API endpoint. And here is the response call, just similar to the Foundry SDK example, because Foundry SDK also we are using or we are creating an instance of OpenAI client. So here is the first request, and here is the response, and here is the second request where I am passing the response ID along with the request. So we get the same response here as well. So first response, and we also got the second response. Same thing can be executed in asynchronous method as well. So like the chat completions example, here we have to create the instance of the async OpenAI instead of just OpenAI. So we have the main method. Inside the main method, we are creating the asynchronous instance here, or asynchronous instance of this OpenAI, and we are making the request here. And you can see each time when I call this API, I'm using the await keyword. So just like the previous one, we have to pass the previous response ID while making the new request. So let me execute this. Yes, you can see the response is generated. So we have tried the responses API with synchronous and asynchronous with the Foundry SDK and OpenAI SDK. But what are the other features we have discussed about the responses API? That it supports multi-model request, which means if you have something there in, some images need to be sent along with your text request, so we can use the responses API. So let's take this example. So here we have a method that is image to base 64. So this method is used to convert the image into a base 64 encoded format. So here we are reading or we are opening the image in the binary mode and then converting that into base 64 encoded format. So this method accepts the image path or image URL as a parameter and returns the base 64 encoded format image. Now here we are creating the Foundry Project client, and using the Foundry Project client, I am creating the OpenAI client. Since now we have to send an image along with the text request, we are passing an array as an input here. So you can see inside this array, we are specifying the type or is message, role is equal to user, and content is again an array type which contains two different types of content. One is the text input, you can see type equal to input text, and this is the question. So what is in this image? Okay. And the second content is an input image type. Okay. And we can specify the detail value or detail parameter value as auto, which means it will give the detail level of the image to be sent to the model. Okay, so we can specify low, high, auto, or original as the values. And here is the image URL, and we need to specify the base64 encoded value to that request. So when you make this request using the responses API, it generates a response, and we can go and print the response. So let me show you what is that image. So here our image is image input. This is the screenshot of a Bing search operation. Okay, so I'm going to use this image to make this request. So let me run this. Let's see what is the response coming from the responses API. Yes, here you can see the response output. It's a screenshot of a Bing search result page for the query OpenAI news. Visible elements, and you can see a Bing logo and the search box at the top with the query OpenAI news tabs under the search box, like the search, news, images, videos, maps, Copilot, and more, so and so. Which means what you see in this image is described by the large language model. So here we are using the responses API to send a multi-model request, because the request now contains a text as well as image input. Similarly, we can use streaming. Suppose if I have to stream the events, then also I can use the responses API with a very simple way. So while creating this response, you just need to add the stream equal to true parameter. So you can see while making the request using the OpenAI client dot responses dot create method, we are specifying the model and the input request. The request, you can see, it can be a simple string message, or it can be an array of dictionary like this. Okay, this is a message format. So tell me about the capital city of France. That's a query. And stream equal to true, which means I want the response to come as a streaming response. So here, this is created as a response stream events, and we can loop through this response stream events. Suppose if it is a response created, means if responses start creating, then we can print the response ID, and if a response text is generating, we can print that response content, whatever is the response content coming, that you can print. And if the response.text.done, which means the response text is completed, access the final text in the event.text parameter. So if the event type is completed, which means the response generation is completed, okay, so we can access the final text in event.response.output.text. So we want to print only the streaming content. That means whatever is the chunks, response chunks generated, we have to print that. So that's why I'm using this event.delta variable. So when I run this, you will be able to see it generates the responses token by token. You can see here it's generating the response. It's a lengthy response, but you can see it is not generating the entire content at once. It is generating token by token, and that you will see. Another major feature which is supported by the responses API is the structured output response. So when you generate the response, typically the response is coming in a unstructured text format, mostly plain text or markdown format. But if I need the response to come in a structured object format, it may be a pedantic model response, or it may be a JSON object, or it may be a typed dictionary object. So we can create structured output, means we have to define the type of the response that we want to generate. So here I am creating a class, a Pydantic model class, calendar event, inheriting from the Pydantic base model. And there are parameters like a model config, extra or forbid, or extra forbid, and the name, str, date, str, which is the date in this particular format, and the participants is a list of string values. So this is the model class. Now I want to make a request, but I want the response to come in a structured output format. So here is the request. I'm using the OpenAI client.responses.create and passing the model name and the instructions. Here you can see extracts the calendar event information from the input messages and return it in the desired structured output format. So in the instructions, I am clearly specifying that from the input event data, get or from the input message, extract the event informations and return that in a desired structured output format. So what is the text parameter, additional parameters that we are passing? Format. So this is a text generation parameters. Format is JSON schema and name of the type is calendar event and schema is calendar event dot model JSON schema. So this will specify or this will tell the model that the output need to be generated in this type or in this for calendar event format, and the schema or the structure is returned by this. Let's see what is the input prompt we are providing. Alice and Bob are going to a science fair in Friday, November 7, 2025. So when I make this request, the output needs to come in this calendar event format, which means we are expecting the participants' names like Alice and Bob to come as participants. Okay, and the date, event date needs to generate in this format, and the event name, maybe science fair, that needs to come as the name. And when I make the request, let's see, here we are making the request. When we receive the response, we can print the output text here, and that is going to return the generated result. So here you can see name. It is coming in a JSON format where we have a name variable. Name is science fair. Date is in the DDYY format, and also the list of participants. You can see Alice and Bob as a list of string values. So here you can see when you're using the responses API, we are able to use streaming. We are able to use structured output. We are able to use the multi-model requests, and we are able to make the synchronous and asynchronous API calls. So when comparing to or compared to the completions API, your responses API provides better responses with more features. So it is always recommended to use the responses API for the new generative AI projects. So that's it for this particular session. Thank you.